Now let's look at the lesson on sets. Now set theory has a lot of real world applications, and it is the basis of group theory. It's a branch of mathematics, but you will find it very useful when we do probability and some other logical problems that helps you in actually analyzing the problem using the set theory. Now, what are sets? Sets are collection of objects. Broadly, when I want to define it in a very broad way, then I can say that sets are a collection of objects or collections of objects. But in math, how do I define set in mathematics? A set is a collection of well-defined objects. So that word well-defined is important. Well-defined objects. So in a class, if there are say 12 students, and I say the set of all the boys who are taller than 132 centimeters. So then I can actually take their height, then take their heights of those students, and then pick out those students who are taller than 132 centimeters. But when I say the set of all tall students in the class, then that doesn't make sense. If I consider somebody tall, the other person may not have the same view. So the well-defined actually helps us to identify the quality and place them in that particular set. So that is what it is. So now suppose the sets are labeled with a capital letter. Sets are denoted using a uppercase letter, a capital letter. Now we have already seen sets. Do you recall whole numbers, then your integers, rational numbers? Those are all sets, and we have used alphabets to denote those sets. So now let me write a set A which has these members, say 5, 7, 10, 22, 40. Now these are members of this set, and how I have chosen these numbers at random, but I put them in this set A. So this is set A having these members. The members are called elements of the set. Elements of the set. The numbers that you see here are the elements of the set A. Now how do I denote that? I use this Greek alphabet. 5 belongs to. So this symbol which I write here is belongs to A. 40 belongs to A. So this you read as belongs to, is a member of. Right. Now when I write 15, no, it doesn't belong to A. So you put a slash across this symbol E. Now this E is a Greek alphabet. It is equivalent to our E in English, the lowercase. Yeah. And it is read as epsilon. In Greek they call it epsilon. Okay. So but then you know that this is the symbol used for belongs to. And then now what are we'll just recall the sets that we know already. Then the number system n starts with 0, 1, 2, it moves on, and you put just 3 dots and then you enclose it. You would have noticed that I've used this braces, this bracket, curly bracket. That is how you denote a set. That is how you write out a set. Now this is an infinite set, and you know why? Because the members of the set are countless, infinite. Now the set A that I mentioned above is a finite set. It's a finite set. So now it is n is an infinite set. So also Z 0 plus or minus 1 plus or minus 2 with the 3 dots and close it. Infinite set. Q, now you can write Q as P by Q, and then you have to define what is P and Q. P and Q are integers, belongs to. So I am using the symbol belongs to. P and Q belong to Z and Q not equal to 0. This is how I can write Q. Now what are how can we define sets? There are three ways by which you can represent set. One is you describe it. That is, you just explain the set in words. That is descriptive form. So this is one way of representing a set. Two, roster form. And the next one is called the set builder form. Now what are these? Descriptive form is just explaining the set. So if I say B is the set of even numbers, even positive numbers less than say 17. So this is, I'm explaining the set in words. So this is the descriptive form. Now next, roster form is listing the set, listing the elements of the set one after the other, just like how we did for the earlier examples A, N and Z. So now in the set builder form, in the roster form, this is descriptive. What I explained is descriptive. Now roster. So B is equal to, you write the elements of the set. All the even numbers less than 17. So you start with 0 or positive. So I don't even have the 0. 0 is not positive, not negative, right? So I start with 2, then 4, 6, 8, 10, 12, 14, 16. So I have written the set in order. The roster, have you heard of the word roster? When you take attendance in a class, we call out the names of students. And it is called the register. That register that contains the names roster. So the roster form is a list that we have where the elements are listed, where the names are listed. So here the elements are listed one after the other. This is the roster form. Now what is the set builder form? Here we use a variable. Now generally we use X, but you are free to use any variable. Don't use O, because what happens if you use O? You will be confused with 0, right? So don't use O. Any other alphabet is fine. So X, and these two dots mean that X such that. X is even. You can give it in short, in brief. X is even, and X less than 17. So this is the set builder form. It builds the set. It gives a rule for the set. So these are the three ways in which sets are represented. So when they give it in the set builder form, this is set builder. It builds the set. And this is roster, when the elements are listed. So when they give it in roster, you will be expected to write it in the set builder form. And when it is given in set builder form, you should be able to write it in the roster form. Why do we interchange? Sometimes if you write it in the roster form, it's easier for you to do operations on sets, which we'll be learning shortly. Okay. Now what is n of b? This n of b gives you the number of elements in b. The total number of elements in b. So n of b is, let us count, 1, 2, 3, 4, 5, 6, 7, 8. N of b is 8. Now what is n of z? It's an infinite set, right? So it is not defined. You can use the symbol infinity, but not defined. You say not defined. For an infinite set, you cannot get the number. Now what about this? When I say the b is this, I'll say C. C is the set of even numbers between 0 and 1. So I've described the set C. C is the set of even numbers between 0 and 1. Do you have any even numbers between 0 and 1? No. That means there is no element in C. C is a null set. It's an empty set. So this is how you write an empty set. Sometimes, most of the time you use this Greek alphabet. This is called phi. PHI. It is pronounced as PHI. Phi, Greek alphabet phi. So either you write this without any element or use the letter phi. And mostly in our in books, textbooks, they use this phi. So it's an empty set. It's also called a null set. In this case, C is a null set and number n of C is 0. Now see the difference. Here I've used the new number 0. But when I describe the set C, I used 5. So you have to know when to use 0 and when to use 5. When I talk about the number of elements, you use the number 0. Now we'll do one more example here. Say P. P is the set. See, I always use capital letter to denote a set. P is the set of, I'm describing it, set of letters in the word experiment. Now write the set in the roster form. So P is equal to, now you write out these alphabets, but don't repeat any element. See, the elements in the set are not repeated. You write it only once. So even though there are two E's here, now you can see that there is an E over here and there is an E. Oh, it repeats 3 times. You are going to write it only once. So E, now X, and you separate the elements using comma. P, R, I, M, N, T. So this is the set of the letters of the word letters in the word experiment. So E is not repeated. That's why, because we already said no well-defined object, don't repeat the elements and separate the elements using comma. Now let A be, now here let us see, do this one. It's interesting. It is an ordered pair. The elements are ordered pairs in this, that is x comma y. I'm giving it in the set builder form. How is this ordered pair x comma y? There are two numbers here within the braces, within the parentheses, x comma y. So it's called an ordered pair. The first one stands for x, the second number stands for y, such that y is equal to 3x plus 1, comma, and the x takes the value between minus 2 and 2. So minus 2 less than or equal to x, less than or equal to 2. Both negative 2 and positive 2 are included. Now what is this? Y is equal to mx plus 1. 3x plus 1. Y is equal to 3x plus 1. This you will learn that it stands for the equation of a straight line. So what we are going to get here is actually points on this straight line. So how do we do that? I want you to list out the ordered pairs, write it in the roster form. So first I take the smallest value of x minus 2 and put it in this equation. So y is equal to 3 times negative 2 plus 1. So it's minus 6 plus 1 minus 5. That's the minus 5, but that is the y value, right? So I have to give it in the ordered form. So what was the value x that I had taken? Minus 2, comma, minus 5. Next, I take the value -1. Here I forgot to mention that x belongs to z. So x belongs to z also, because I cannot be taking all the decimals and fractions and irrational numbers between these. So let me take x belongs to z. So that completes the set builder form. So the next higher number, next for the successor of -2 is -1. So 3 times -1, -3 plus 1 -2. Next, after -1 you have 0. So 3 times 0 is 0, 0 and 1. So this is the next ordered pair. Then you have your 1. 3 times 1, 3, 3 plus 1, 4. So you can see that the first position is occupied by the x values. The second position in each of the ordered pairs is the y value. Then the last one is 2, 2, 7. So here there are 5 ordered pairs in this set. So n of a is 5. And what are these? These are points, 5 distinct points on the line when you graph y is equal to 3x plus 1, a straight line, and these are 5 points on that line. So this is one other example in sets where you can have ordered pairs as elements. Now we move on to subsets. Now I can say that A is a subset of B if all the elements of A are also elements of B. Now one small example quickly. B is the set which has 1, 2, 3, 4, etc. up to 10. See, I'm not writing all of them, I'm just writing the dot dot 10. And A is the set 2, 4, 6, 8, 10. Now you can see that 2 is in A, it's also in B. 4, it's also in B. 6, also in B. 8, also in B. 10, also in B. So we say that A is a subset of B. And how do I denote this? I'll just use the symbol here. A is a subset of B. So the C just elongated. That is, A is the subset of B. Now what about A and A? When you compare A and A is a subset of itself. Because all the elements of A, again, they are all in A. So you can also say A is a subset of A itself. And in fact, we don't say subset. We use when they are one and the same. We say A is equal to. But it is also correct if I say A is a subset of A. This is also right, but this is the best way of saying A is equal to A. So when I have A is equal to, let me use alphabets now, A, B, C and D. And if I have B also, but I can put it in a different order, that's also fine. But it also has the same 4 elements, exactly identical elements. So I can say A is equal to B. I can also say A is a subset of B. I can also say B is a subset of A. All these 3 are true. Now, what about if I take C to be B, C, D? Now, C is a subset of A. I don't put equal to now because the number of elements in C is less than the number of elements in A. Similarly, I can write C is a subset of B as well. Now here C is called the proper subset, is the proper subset of A or B. So when I use the word proper, then the number of elements in the subset will be less than the number of elements in the bigger set. And some books they also call the bigger set as superset. Now let us take the set, two or three sets for example. So A I can take as 3, 5, 7. B I can take as 1, 2, 3, 4. C maybe 0, 4, 7 and 8. Okay. Now I have another set called the universal set. What is this universal set? It will contain all the elements that are in A, B and C. That means a universal set is a bigger set and we are considering subsets of this universal set. So here I am going to consider A, B, C as subsets of this universal set U. Now it is denoted by U and they use although this capital epsilon like this. Mostly we use the U and this is also very commonly used, universal set. Now I'm going to define the universal set as 0, 1, 2, etc. up to 10. Now you can see that A is a subset of U, B is a subset of U, and C is also a subset of U. Right? Now what is complement of a set? Now complement of a set is in relation to a universal set. That is all the elements that are in the universal set but not in that particular set. Say complement of a set. Now when I say A with a dash over there, you can read it as A prime or A dash, A prime. So in some books they denote it as A with a small c, A complement. Now A complement is the elements not in A, but the elements which are in U. So here what are the elements of A complement? A complement is a set. It consists of elements not in A. To put it in a very simple way, elements of the set not in A. So the elements that are not in A. So what is A complement? You have to remove that 3, 5 and 7 from the universal set. So you have 0, 1, 2, don't write the 3, write the 4, 6, 4, 5, 6, don't write 7, 3, 5, right? I cannot write the 5 also. See, I am not supposed to write 5 because it should not be in A. So 4, 5 is not written, 6, 7 is not written, 8, 9 and 10. This is A complement. What is B complement? I can use the prime, the dash, or I can use C. So B complement will be, I have to remove that was 1, 2, 3, 4. So 0, then it starts with 5, 6, 7, 8, 9, 10. So A and A complement put together will give you your universal set. B and B complement put together gives you the universal set. So now we have learnt about complement of a set. Now we are moving on to operations on sets. The first one would be the union of sets, denoted by the letter U. So when I say A union B, I have to list all the elements in A and B. So let me see what are all the elements in A and B. We'll go to the same example. 1, 2, 3, 4, 3, 5, 7. So 1, 2, 3, 4, 3, 5, 7. 3 I don't write 1 because already written. 5, 7. So this is A union B. The elements in A and also the elements in B. So what is B union C? What do we have in B? B is 1, 2, 3, 4. This is 0, 4, 7, 8. 0, 4, 7, 8. So list all the elements that are in B and also in C and put it in order. Generally, we like to write when it involves numbers, we like to write it in ascending order. It looks nice if it has the ascending order, right? B union C. Next, so you know what is union. A union B is a set. Remember, this is not something different. A union B is also a set. B union C is also a set. Now next is intersection of sets. Here the symbol is this, the other way around, upside down of that U. So when I say A intersection B, the elements common to A and B. What are the elements common to A and B? You have A357, B1234, just one element is common, which is 3. So you write 3. So the intersection is the element common. So now for example, I give another two sets D. D is equal to some A, E, I, O, U, the set of vowels. And E is the set of M, N, Q. Now D intersection, I'm not D, D intersection E. D intersection E would be, now do you find any element common? No. There is no element common to D and E, so it's an empty set. You can write it like this or a null set. Now how many elements are in D intersection E? Nothing. So you put a 0 there. When it comes to number, I use the number 0. If it is a set, you use you denote it by 5. So that is intersection of sets.